Okay, so today we are going to be talking about evaluating trigonometric ratios given a point not on the unit circle. Okay, so what is important here is the first thing is again, determine what quadrant we're in. Okay, so when I'm looking at number 1, it says the point 4 comma negative 6 is on the terminal side of an angle, theta, in standard position. Determine the exact values of the 6 trigonometric ratios. So, how do I determine what quadrant I'm in? Well, it's based on this point. Based on this point, right? Okay. So how would you normally get to this point? And I know this might be a little confusing, but I'm going to draw this triangle, maybe not right side up because it helps me understand my signs, right? So when I look at this point, I say, okay, I'm going left 4, down 6, and in the corner there. So left 4, down 6. So that means here I'm in quadrant 4. I'm in quadrant 4. So think about all students take calculus. All students take calculus. So that means that cosine and secant will be positive. Sine, cosecant, tangent, and cotangent will be negative. Okay, so all students take calculus, right? Well, the first thing I have to do is I need to find my radius or my hypotenuse. Okay, remember, this is not on the unit circle, so therefore we do not have to have a radius of 1. So I'm going to use Pythagorean theorem. So I'm going to do a squared plus b squared equals c squared. So that's going to give me now 4 squared plus a negative 6 squared equals c squared. So that gives me 16 plus 36 equals c squared, which now 16 plus 36, that's 52, equals c squared. So then what is c going to equal after I square root both sides? Okay, what is it going to equal after I square root both sides? So we're just going to plug it into the calculator real quick. And you're going to get 2 root 13. Now again, this is my radius. Okay, I've had students mark this negative before. Remember, radius is the distance from the center to a point on the circle, right? So our radius is never negative. The only thing that can ever be negative is one of our side lengths, right? How did I get here again? I went right 4, down 6. That's why 6 is negative. Okay, if I would have gone left 4, then 4 would have been negative, okay? So now what we have to find is based on where theta is located, and now we have all of our sides, we need to find sine, cosine, tangent, cosecant, secant, cotangent. Okay, so let's go ahead and let's find sine. So sine theta, from where theta is, right? And guys, again, theta always goes up in the corner, right? It's closest to the origin, okay? All right, closest to the origin, all right? And so when I'm trying to find sine here, sine's equal to opposite over hypotenuse. So opposite negative 6, hypotenuse 2 root 13. So I've got 6 over 2 root 13. Okay, and ideally, guys, what you should do to save you time is use your calculator here. So go fraction button, negative 6 over 2, okay, square root button, 13. Save yourself a lot of time there. Okay, hit enter, and there you go. It's going to simplify it for you. All right. If you don't, then you rationalize by whatever the radical is. I do not need to have the 2 there. Okay, I do not need to have the 2 there. All right? Because I'm only trying to get rid of the portion where there's a square root, and that's just 13. And so when you end up doing that, yeah, you're left with now what? Negative 3 root 13 over 13. So use your calculator, okay? Cosine theta, same thing, based on here, adjacent over hypotenuse. Now we've got 4 over 2 root 13. When I rationalize it by multiplying both sides by root 13. Okay, again, use your calculator to make it easier on you. Fraction button, 4 in the numerator, over 2 times root 13. Hit enter, and there you go. So you get 2 root 13 over 13. Okay, tangent Thankfully, very easy here. Okay, opposite over adjacent. So negative 6 over 4, which then that ends up being a negative 3 over 2. Please simplify. Okay. Cosecant now, which is the reciprocal sign. And usually what I say to you guys is I say, okay, yeah, just flip your answer for sine. Now, if I was to do that, then I'm going to have to rationalize again. So what I'm actually going to flip is actually at the beginning here, which it doesn't matter whatever at what point, right? You can flip it at any point. And the reason why I'm going to do this is watch, look how much easier this gets. Now I've just got a negative 2 root 13 over 6. And now I don't have a radical in the denominator anymore. So therefore, I can go ahead and now just simplify. Well, what does 2 over 6 simplify down to 1 over 3? So then your final answer is going to be a negative root 13 over 3 for cosecant. Secant of theta, I'm doing the exact same thing. Okay, I'm flipping cosine at the beginning here to avoid having a radical in the denominator. So I'm going to go 2 root 13 over 4, which now simplify. What does 2 over 4 give you? 1 over 2, and so your final answer is going to be root 13 over 2. And then now tangent, cotangent of theta. Okay, very easy. I'm just taking, and you can take the original or you can go flip here at the beginning. But since there's no radicals whatsoever, I can use the final answer to flip. And so you just get 2 over 3. Okay, and there's your answer. Okay, so really just understanding what quadrant you're in, drawing the triangle, okay, drawing the triangle, and then coming up with your trig ratios. Okay, so now on this next one here it says, okay, find cotangent of theta if sine of theta is equal to 1 over 4 and is in quadrant 2. So I know I'm in quadrant 2, so I'm going to draw a triangle going in quadrant 2. How do I get to quadrant 2? Guys, I go over left, up, and that's how I get to quadrant 2. Again, theta always goes closest to the origin. So our theta is going down there, and let's label what we know. Well, what do we know about sine? We know sine is equal to opposite over hypotenuse. So that means the opposite length side should be 1, your hypotenuse should be 4. So we're going to go 1 here and 4. Now, I need to find this side right here, okay? So I'm going to do what we did over here is I'm going to do Pythagorean theorem. So that's a squared plus b squared equals c squared, okay? Recall, a or b, one can be plugged in for a or b. 4 has to be plugged in for c. So I get 1 squared plus b squared equals 4 squared. Okay? And so, continuing on, that's going to give me now 1 plus b squared equals 16. Subtract the 1, so you're going to now have b squared equals 15. And so that means then that b just equals the square root of 15. Shoot, that's too close. Sorry. So square root of 15 here. Now, the only thing is I'm in quadrant 2. So what do we know when we move left? That associates a negative. So I'm going to put a negative sign in front of there so that helps me. Okay, that helps me to remember that this term down here is negative, because the biggest thing you can forget about, guys, is your signs. Biggest thing you can forget about is your signs. So I've got negative root 15, 1 for my 2 legs, and then my hypotenuse is 4. Again, why is 4 positive? Because, again, it's our hypotenuse, it's our radius, has to always be positive. So then now it wants me to find cotangent. Well, remember, cotangent of theta is now equal to adjacent over opposite. So then in this case, then, cotangent of theta is equal to adjacent, which is negative root 15, over opposite is 1, and so then my final answer is just that cotangent of theta is equal to a negative root 15. Okay? So not long, guys, okay? I mean, again, you just got to set it up the way the question is asking you to set it up. And I know for me that sounds simplistic, right? Because I've done this for a while. But again, just ask yourself. You got to determine what quadrant am I in. That's how it starts. Draw the triangle based off of how you get to that quadrant. And number 1, how do I get to quadrant 4? I go over right, down, right? How do I get to quadrant 2? I go left and then up, and then you draw your triangle, connect the two lines, right? Okay? So really that's it, guys. Again, great week. This is our Friday lesson, not super long. We'll get through it. And then, yeah, we'll enjoy our week and then start getting ready for the test next week. All right, thanks, guys. See you in class on Friday.